It is a great honor to be able to be here and to make a presentation regarding weather control. So you all may know the acronym indicates. So ELSI stands for ethical, legal, and social issues. I just talked to Sarah in the restroom. So in the United States, they don't use this acronym, but this acronym is from United States Human Genome Project in 1991. So we use this acronym so strongly in Japan. Okay. So let me introduce myself first. My name is Manami SASAOKA. My main field of research is not methodology. My profession is law, and especially commercial law, transportation law, maritime law, area law, and space law. It is my profession. So I joined the FDIAS project in 2021. And I am working as a principal investigator, shortly API, for ELSI on typhoon control in that project. Okay, as you all may agree, a weather control activity can be implemented only when these three basic conditions are met. First, the activity should be based on accurate scientific and safe technologies. And second, society must be able to afford the cost of that activities. In addition to these two conditions, the political decision regarding the implementation should be made before it works. And such a decision should be supported by society with the acceptance of the risks involved in that activity. But how can we assess whether society accepts such risks? It is a very difficult question. More fundamentally, what are the risks that society faces, and who are the stakeholders in terms of the weather control? This is a very, very difficult question. The scientific knowledge would help to increase social acceptance, but it does not necessarily address all concerns. So for this reason, these issues are referred to as trans-science issues, the trans-science field. So let me explain the strategy that Moonshot Goal 8 takes in this regard. It is usually said that the emerging technology would go through the technology control dilemma, calling glitch dilemma, another term, which means that at the beginning it is difficult to detect risks because the project has not been consolidated yet at the beginning. But when the risks become apparent as a result of research and development, it is not easy to manage the risks by controlling the project due to over-expectation of the implementation. So to solve this problem, this dilemma, Moonshot Goal number 8 takes the ELSI and RRI approach. The point of the ELSI approach is that the core research project needs to hold an ELSI team to let it consider probable social benefits and concerns. And the ELSI team is expected to work concurrently with the development of science and the technology team. So Moonshot Goal number 8 also adopted the RRI approach, responsible research and innovation, which indicates a self-governance mechanism. This mechanism will be fully effective in the early stage of development where there is no specific mandatory safety regulations. This slide shows our research timeline. Please look at the left edge of the timeline. As you know, at this stage, there are a lot of uncertainty or indefinite factors. So we don't know what technology will be applied, method, scale, operation area. We don't know very much about it. So At this stage, I have said before, it is difficult to define the risks and to provide a proper regulation according to these risks. It is very difficult to define the risk at this stage. The only thing we can do at this stage is to study every possibility to of benefits, risk, and the concerns and the changes in society, so that we can gradually reduce the unknown and indeterminate factors. This step-by-step approach is called a forecasting approach. Through this forecasting approaches, we are now currently standing just before the small-scale experimentation phases. So hoping it will happen in 2030, so we are now progressing. At first time, we were standing here, but now we are here. At the same time, we are predicting the future when weather control technology were implemented. Please look at the right side of the timeline. The target year of the implementation is 2050. First, we examine a minimum environmental and institutional requirement for typhoon modification, which we don't have yet at the moment. So please look at this slide. So we need at least any safety regulations, responsible department, liability compensation regime, international cooperation. It is at least so when implementing typhoon control technology into society. To get such a situation, we examine what we should focus on before 2040, which is the target year for field experiment to real typhoons. This way of thinking is called our backcast approach. We are doing research with the combination of these forecasting and backcasting examination approaches to deal with typhoon control. I can tell you about the other good feature of Moonshot Goal 8. As you know, we have 4 different core research projects, and each has 1 or more LCPIs. Each project is divided by target weather event, intervention method, or other aspects, but the LC consideration would not be so different. So thus, a joint group of LCPIs with some advisors was formed in 2022. We have been working together on a regular basis ever since. This indicates how we work together. I'm sorry, this slide written in Japanese, you don't need to try to read it. It's very small, too small. And I will go into these categories in the following these 3 slides. So let me explain how we work together. So at first, we share information from each project and discuss relevant issues and conduct joint surveys and feed the result back into our own project. So as a preliminary result of the joint group, we have roughly classified the 6 LC fields to be investigated in further studies. Okay, this is a visual representation of 6 categories. Okay, let me briefly explain each category. Weather control would address both global or transboundary risks and regional level risks. The management of these risks would eventually lead to appropriate regulations such as treaties, national laws, or other normative forms. So categories 1 and 2 deal with these issues. Categories 3 and 4 deal with the long-term effect of weather control on society, nature, and culture. It is usually stated that if the weather becomes controllable, society will much more vulnerable. So if the typhoon is controllable, some people would go outside even if the rain is heavy. So society would get to more vulnerable due to control technologies. Therefore, we need to find a way for weather control technologies and a sustainable society to coexist. In the face of nature and culture, we need to pay attention to languages and terminology. There will be the gap between the scientific jargon and the general perception of the same words. For example, according to an English dictionary, the term control means the power to make a person or thing do what you want. So some people will feel uncomfortable when we try to apply such power to natural weather systems. So we need to use words carefully and closely communicate with actors having different backgrounds. Number 5 is about the decision-making process, and number 6 is about responsible research. So we divided the ELSI issues into these 6 categories. So there is a lot to discuss, but today I would like to share with you some of our thinking, just focusing on the category number 1. Within the joint group, my team's main focus is on number 1. The most conceivable international risks are some negative effects caused by control operations. So we can classify these effects into 4 categories, 4 cases. Case 1, seeded substances, for example, silver iodide, were thrown directly to third-party premises, soil, or public areas. Case 2, the short-term weather or environment was changed by the operation. It includes the case in which the typhoon truck was curbed. Case 3, the long-term environment, biodiversity, and climate have been changed by the operation. Case 4, situations such as those described above cause political, social conflict and instability. The proximity with the operation and the result becomes gradually distant from case 1 to case 4. Based on these cases, let me examine how we could manage the risks of harmful result. First of all, it is completely forbidden to use weather control technology for military or other hostile purposes. The UN Convention MMOD 1976 draws a baseline for all weather control activities. And this will be applied to all cases above. It should be noted that the same MMOD convention rather encourages weather modification for peaceful purposes. So, but even if it is done for peaceful purposes, there will be some restrictions if it clearly brings harmful results in other countries. It is quite conceivable, especially in case 1 above, because it relates to direct effect. But in other cases, as well, it would also happen depending on the situation. There is no international agreement what the states should do in this case, but it is generally recognized in international customary law that every state is obliged not to harm other states. This rule is called as the non-harm principle. So more specifically, some convention directly and clearly regulate dumping substances into the air or the sea. We must confirm the permissibility of operation according to these existing norms. The next question, if harmful results are only a possibility, what should the operating states do in advance? This will be the case in which any scientific uncertainty in the operation remain. Some international instruments refer to the obligation to conduct an environment impact assessment. In addition, based on the well-known precautionary principle, any risky weather control activity will be stopped because it might cause a harmful result. Here, we will recognize a serious challenge called the risk versus risk situation, which means if the operation were prohibited under the precautionary principle due to the risks, the society would end up losing one possible measure to avoid severe risks from disasters. So we have to decide which risk we can emphasize more. So we also examine whether it is ethically permissible or justifiable to impose a risk on the other side, or we may build any cooperation systems to share the risk, sharing the risk systems. Let's move on to the next situation. If some harmful events occur beyond expectation, the operating states would be liable to the victims as long as the causation link is established. The point is, first, what kind of liability system is appropriate for weather control, negligence-based, or strict liability? And also, do we need to introduce a new compensation system, such as the loss and damage fund introduced by COP28? It is because as you see in cases 2, 3, 4 above, especially in case 4, it will be difficult to establish the causal link between the control operation and the result. So it is too far to connect the operation with the result. So before implementing weather control technologies, the international society would compel to introduce such fund to recover any losses from the operation. So we ELSI team should examine what is the most appropriate compensation system for weather control activities in question. Okay, that's the end of my presentation. In this short presentation, I could not cover whole issues we are addressing. So if you have any comments or question, please feel free to ask me. So we will stay engaged and closely connected with members in Moonshot Goal 8, including the joint ELSI research team. So also we will communicate with societies, several actors, both at domestic level and international level. So by doing so, we hope to be able to promote further international cooperation. Thank you for listening. Thank you.